Good morning, good afternoon, everyone, depending on where you are tuning in from. It's a cold and crispy morning here in Quebec City. We're happy to have you here with us today for this Robotiq 4-stork sensor webinar. Today is an application webinar, so targeted to see how the new redesigned FT300 can help you achieve new applications. Today we have Louis Bergeron, one of the coaches here at Robotiq. He will be the main presenter. We also have Laurence Bellimard-Robert, channel sales manager here at Robotiq, to answer all of your questions on the chat or the private question. So make sure to tune in to fill in your question in the chat or question box on the right side of your screen. There are also 3 handout documents that you can download. There is a application matrix, a FAQ, and important links that will be discussed in today's webinar. So feel free to download them, and you will be able to keep this document and share these with your team. So without further ado, Louis Bergeron.
Hi everybody, and welcome to this 4-stork sensor application webinar. During this presentation, we will do first with a quick look about what's new with this product since the last months. Then we will focus on applications. At the end, I will show you how to do a quick demo for your customer that show also how to easily implement this sense of touch in the programs. First, in September, we have changed the electronic board inside our FT300 sensor. With the new electronic, you can see the new specification in yellow here, that now the signal noise is up to 10 times lower than before, and which also a lower detection threshold for your applications. Since a few weeks, we have launched a new UR caps for the 4-stork sensor. With this UR caps, you will get this new dashboard showing at all time the force and torque values coming from the sensor. Also in this new UR caps, the calibration of the sensor is now integrated in the installation tab. There's no more need to load the old Calib tool programs. The integrated calibration wizard is then more visual and really more easy to use than before. The new calibration wizard will also give you an estimated payload and also the center of gravity to make your tool configuration more easier. With this new release, you don't need to start your program with the template sensor anymore to get the instant value of the force and torque. All your program now have an instant access to the measured force and torque, and you can use the functions directly listed in the UR interface to get those values in your program. And since September, we have launched a new product named Skills. From the website skills.robotiq.com, you can freely download pre-packaged functions using our product to make your program more simpler, cleaner, and easier to use the function like the force and the torque in your programs. We will continue to improve and add more advanced skills to unlock possibilities to you and your end customers. And I will show you during this presentation some of these skills related to the 4-stork sensor. Now let's see how the 4-stork sensor can assist you and the end customer on these kind of applications. For the machine tending is a really good market for the 4-stork sensor. Let's take a look at why the 4-stork sensor can increase productivities for the end customer in this kind of application. There's not only one reason to use the 4-stork sensor in the machine tending applications. We will look at all these reasons one by one. First, the end guiding of the robots will be really more easier with the use of the 4-stork sensor by the tool named Active Drives that you may probably already know. With these tools, it will be really more easier to handle and position the robots to teach any kind of programs. And often a UR10 is used in this machine tending application, and the Active Drive is particularly useful to handle this robot model due to his weight. And if the customer will have to make some program by himself, he will be very happy to reduce his programming time and then his cost for those programming. The goal of a machine learning application is to produce mainly parts, but not only parts, but good parts. If the part is not positioned correctly in the machine, for example, you know the result, we're going to have some bad parts. And to ensure a good positioning of a parts, against mechanical stops, for example, the sense of touch with the help of the skills linear search can help produce a good part on these applications. As you can see in the video here, with just simple line of programs, we can have ensure that the part goes against the mechanical stops by the fields of the Vostok sensor and the ease of use of the simple linear search instruction in the Z, in the Y, and in the X directions to position the parts correctly. This sense of touch can also make machine learning application more reliable. In the same ideas as previous, if you can detect some problem, you will increase the amount of good parts, then increase the return of investments. Here, I will show you, for example, in the machine learning, you can see here in the middle, if we got at some points a chips, for example, stuck in the vise or in the chucks, if you do the parts with that chips in the machines, you're gonna probably produce bad parts. But here, with the sense of touch and the help of the linear search instructions, you can detect that there is something in the chuck automatically to ask the operator to remove to make a verification. Then afterwards, you're gonna have still this contact with the mechanical stops to help produce really good parts with your machines. One of the difficulties to make application really reliable is to ensure that all human interventions are made correctly. Did the operators select the right robot programs? Did they select the right CNC machine program? Did the operator place the right raw material in front of the machine? Are they at the right place, in the right orientations? It's really hard to prevent all of this. But by having the Vostok sensor and the skills collision detections, some of these issues will limit the damage to the robot's toolings and the equipment around the robots, and then the downtime and damage will then be reduced. As for example, here, if we have, for example, parts, raw material placed incorrectly, the skill will monitor at all time the actual force and torque in all the running programs, and it will stop automatically the program at any moment if these values of force or torque exceed an amount of threshold that you can set by yourself to protect your investments and reduce the downtime. And here for stacking and unstacking, even if the UR has an integrated SIG functions, doing it with the sensor will give you a more sensitive way to do it. It will be more gentle with the parts, with the robots and the equipment in general, and can be really implemented, as you can see here in the videos, with simple linear search. You're gonna see a real gentle touch on top of that stack to make some relative move afterward to do the stacking or destacking operation like this. Now let's talk a little bit about assembly application. The Vostok sensor is definitively a must in this application for a lot of reasons. We have already talked about two of these reasons, a better and guiding utilization of the robot with the active drive, and also the additional protection it may produce on these applications. Those reasons still apply, but let's take a look about the additional reasons to add the force flux sensor in assembly applications. We have already seen how the linear search skills can ensure contact to mechanical stop, but the skills will also be really helpful for all insertions tasks. These skills will help you detect any misalignment, position variation, or parts that can occur during assembly. Rather than putting the robot in a protective stuff in these situations and generate damage, here you can see in the videos that all insertions tasks can be done with the linear search, and these functions will detect any obstacle in the path of these insertions. I will show this example in big. It will be, you're gonna have a better see. The linear search will detect any obstacles in the insertions movements, and it will be stopped if an obstacle is found. The skill will return you to the information true or false if something is found in the path. So you can implement a logic to see that the insertion is made correctly. By using this information regarding if the insertion is done correctly or not, you can also implement with the skill spiral search and make the robot find the hole by himself if the insertion didn't execute it correctly. As you will see in the videos, if at one point the insertion is not done correctly, with the skill spiral search, the robot with the help of the force flux sensor will search for the hole to finish the insertion task. The customer will then have a more productive applications, having the robots finding by himself the correct placement of that hole to carry all kind of variation in the productions. The same kind of insertions may not end up correctly because of a little mismatch in the part orientations. In these situations, you can implement a rotation search skill that can be used to let the system find by himself the correct orientations. Let's see in the video here. We have a little shaft to insert in the hole, and there is a flat. So if the orientation is not done correctly, the rotation search skills, will simply find that correct orientations to complete the insertions. If for another assembly task an amount of torque is needed to be reached, then we have the torque turning skills that can be used to accomplish that kind of task. As you can see, in one single line of programs, the complete sequence of closing the gripper, turning while verifying the torque if it reached the the desired torque, and then if it's not achieved, it will open the gripper, goes back, and try again until the amount of torque is reached. So just with a simple line, you can now do this kind of assembly task quite easily. You will see soon that the torque will be reached and the assembly will be finished right here. So now let's talk about finishing application like sanding, polishing, deburring. Certainly the force flux sensor is a good fit for those applications. You will still get the active drive advantage and also the collision detections, but also some more reason to use the force flux sensor. Certainly the path recording options, the path recording node is a great tools to implement those kind of applications, particularly when you have small batches and you have quite a complex path. then the operator by himself, they will be able to teach these kind of applications quite easily by the use of the active drive and the path recording options. Just for you to know, with our latest release of the UR caps, the constant speed have been really improved in the path recording node, particularly when you have a tool orientations change. Now I will show it to you with this example. When we have some orientation change, previously the speed was quite hard to keep at the good speed. And in the graphic on the bottom right, you can see the TCP speed with the newer caps now is really more accurate and constant. By using the relative options of the path recording, finishing application like dispensing or deburring can be adjusted and tuned to get a really good result. Even if the height of the part is changing a little bit from parts to parts, the surge capacity with the sensor will allow adjustment of that path to be executed at the correct place. More information about how to do this can be found in this free to download application package. You can download from the resource center from our website, and it explains you how to adjust those path recording to have a good finishing or deburring application, for example. Now for quality control and testing applications, the force torque sensor is also a good fit. And we will see now the specific reason for these applications, why the force torque sensor is a good choose. First, you will certainly get a really accurate measurements for quality control, like Pokayoke applications to detect good or bad parts, and you will be able to measure the correct values, the highest torque or the maximum force for an insertion, for example. Another package can be downloaded freely. This one will explain how to implement this kind of measurements to detect the maximum force or torque for a specific movement in the robots to implement this quality control application with the force torque sensor. And if in a specific application your customer need to log the measured values from the sensor or the calculated result in a variable, and you want to export these values to an external PC to store them, you can download this free package on our resource center. You will get documentations, example, and PC programs to store information variable in a standard CSV file format. Now I will show you a simple way and a fast way to do a demo to your customer. And this demo will not only show the easy handling or the path recording, but also how to simply the sense of touch can be implemented in a program with just three simple line. First, before the meeting with the customer, just be sure to be ready and have your force torque sensor calibrated. So be sure to have your force torque sensor, and you can now use in the installation tab the calibration process. Make sure it's done before meeting the customer. And with the customer now directly in the dashboards, you will be able to show him at any moment the force, the torque, and the sensitivity right on the dashboards. And then afterward, you can certainly show the end guiding with the active drive we have to show him how now easy he can handle the robots. And to make the demo, just start a new empty programs and then teach starting points with a standard move. And now with the help of the active drive, you can certainly show how to easily position at the nearest 90 degrees, which is a really great tool for programming. And then also by showing the SCARA mode, you can show that is really easy to handle and keep that robot in the correct positions to teach his programs. Then teach that per starting point. And now to show the implementation of the sense of touch, we will use the linear search functions with its default values parameters. To use those default values, we need to make a move not farther than 20 millimeters from the surface. So you can use the active drive to position on the new waypoint not farther than 20 millimeters from the surface, and teach this new waypoint. And then afterward, just by selecting script code in the structure, here, script code, you can select in the function list of the UR directly the linear search instructions. Be sure to have installed the skills before meeting with the customer. And by removing all those parameters, you will simply use the default values. And you have a really simple programs with 3 lines. And now you have this sense of touch right in your programs that you can show to the customer. For example, to position parts to mechanical stops in the machines, for example, you can show him by just touching the robots that now he have implemented this sense of touch in his program in just 3 single line of programs. Here is a quick guide you can keep as a reference for all those features of the force sensor, and in relation with different kind of applications. You can download this page right now on the webinar dashboards on the right of your screen. And here you can see you will be able to receive it. And here is the important thing about this webinar. You can also download this page right now on the webinar dashboards on your right, and you will also receive an email next week to have a follow-up about this webinar. And in this emails, you will also get those links. And on these links, you can now directly goes to the skills I've shown to you, and also all the links for the application package and all sample programs I've shown in this webinar. You can download them right here to see by yourself those programs.
Great. Well, thank you very much, Louis. So before we go to, we have a question here today. So before we go to this question, just want to remind all of our listeners that we do have some handouts documents. So if you want to download the FAQ, the application matrix, or the important links, there are 3 PDFs to download. If you are listening at this, the replay of this webinar, all of these links are embedded in the email. So feel free to upload them and share them with your team. So before we go offline, we have a question. So Louis, a frequent question is, if the signal noise is 10 times less, why is the recommended threshold is not 10 times less as well?
Simply because at this level, just at the 1 Newton level, it's a really low force. And even if our sensor is really sensitive now, even just the little vibration of the robot or the acceleration to make a motion to the robots can be more than this sensitivity of our sensor. That's why the recommended threshold on some values has been kept a little bit higher than the sensor can be done by himself, just to cover just this motion of that robot or accelerations. We are too sensitive for robots, I think so.
Well, that's good news. So great. Thank you very much, Louis. So we do not have more questions today. If you have questions, feel free to contact the support here at Robotiq or your local channel sales manager. Same thing if you are watching this webinar as a replay, feel free to send us your question by email. Thank you very much. Thank you very much for being with us today, and we look forward to our next webinar after the holidays in January.